Welcome to Simplified Physics. In the previous lecture of dimensional analysis, we have discussed about the problems under dimensional analysis. Some problem we have discussed. In this lecture, we'll discuss some more problems related to dimensional analysis. And don't forget to subscribe, share, like and comment. I'm waiting for your suggestion. May forward to the comment or to the mail link address you may forward to. Let's begin today's lecture. The first problem is 60 joule per minute on a system. We have to convert into a new fundamental systems which has 100 gram, 10 centimeter and 1 minute as a fundamental units. Let's convert. How to convert 60 joule per minute? The given physical quantity here is 60 joule per minute. Convert into 60 joule per second. So 60 joule per minute into joule per second, that is 1 joule per second. And the dimensional formula corresponding to the 1 joule per second is, now for the joule, it's a unit of the work done, that is ml2 t minus 2. This is the unit of time, so t simply we'll get m1 l2 t minus 3. So the given physical quantity has the dimension 1 for the mass, 2 for the length and minus 3 for the time. That means simply a equals to 1, b equals to 2 and c equals to minus 3. Those are the dimensions for the given physical quantity q. Now let's convert for the given system and to new system. n1 equals to 1 is given, m1 1 kg, l1 1 meter and t1 1 s for the SI system, that is joule per second. Now we have to convert to the new system and find the value of the n2, and m2 is mentioned, that is 100 gram, l2 is 10 centimeter and 1 minute, t2 that is as a new fundamental units. Now use the relation n2 equals to n1 m1 by m2 power a, l1 by l2 power b, t1 by t2 power c. Just replace the values. n1 equals to 1, m1 equals to 1 kg, m2 equals to 100 gram is here. Similarly replace l1 by l2 power b, b equals to 2. Similarly t1 by t2 power c. Now convert into the similar system for the first term. This term 1 kg equals to 1000 gram and 100 gram, as it is gram and gram cancel, 2 zeros cancel, that is 10 is left from the first term. Similarly 1 meter equals to 100 centimeter, 10 centimeter as it is cancel once again, centimeter cancel, 0 and 0 cancel, square of 10 is left, that is 100. And similarly convert into 1 minute and simplify it, you will get these values. 10 into 1000 into 216,000. Simply n2 equals to, we will get 2.16 into 10 power 8, and we can conclude that 1 joule per second, or that is 60 joule per minute, equals to 2.16 into 10 power 8 new units. And new system of unit is not mentioned, just mentioned as new units. In this way we can convert from one system of unit to another system of unit for a given physical quantity. Now let's begin for the next problem. The unit of the length, mass and time are doubled. Is there any changes in numerical value in the measurement of the energy? The given physical quantity is energy, and the dimensional formula for the energy is ml2 t minus 2. So energy has the dimension m1 l2 t minus 2, that is mass has the dimension 1, length has 2 and minus 2 is the dimension of the time in case of energy. Now we have to convert from the, we have to check whether there is any changes in the numerical value. So use this formula, n2 equals to n1 m1 by m2 power a, l1 by l2 power b, t1 by t2 power c. The condition is mass, length and time are doubled. So just replace the values in the formula. n1, there is no idea is there any changes in the n1. n2, so n1 it is given as it is m1 equals to suppose 1 kg. If 1 kg is chosen as m1, then the quantity mass is double, so m2 must be 2 kg and a equals to 1 dimension of the mass. Similarly 1 meter if chosen for the L1, L2 must be 2 meter, and 1 second 2 second, b equals to 2 and c equals to -2. Same way. Now cancel the kg, that is 1 by 2 power 1. Cancel the meter, that is 1 second 1 by 2 power 2. Cancel the second, that is 1 by 2 power -2. 1 by 2 power -2, 1 by 2 power 2. These two terms are cancelled. Only 1 by 2 is left, so n2 equals to half of n1. So numerical value will be half of the original value. In this way we can convert, or we can simply find how there is the variation in the numerical value of a given physical quantity from one system of unit to another system of unit. Let's see the next problem. The next problem is the distance covered by a particle in time t is given by a relation s equals to a plus bt plus ct square plus dq. Find the dimensions of a, b, c and d. The most important point is 2 or more terms can be added if they have identical dimension. That's an important point. And dimension on the each term on the left side must be same as dimension on the right side. So each of these terms, yes, a, bt, ct square plus ct and dq, all must have same dimension. All these 5 terms must have same dimensions. So dimensions of s must be same as dimensions of a. Here s is the distance covered, so dimension of the s is l. So as dimension of the a is same as dimension of the s, dimension of a also l and s. Now again, dimension of bt is same as dimension of the dimension of the s, or dimension of the a. Dimension of the a must be same as dimension of the bt. So a, b, t is the time, dimension of the time is t. So dimension of the a is l, dimension of the b and t as well. So dimension of the b is simply lt minus 1. Similarly, we can find the dimension of the c and d as well. Once try to find on your own. Pause the video and proceed to find dimension of the c and d as well. In this way we can simply find the dimension of a, b, c, d. The most important point is all the terms in a physical relation must have the same dimension. We use just and 2 or more terms can be added if they have same dimensions, and the dimensions on the each term on the left side and the right side must be same. Using this concept we can find the dimensions if 2 or more terms are present in a physical relation. Now let's see the next problem. A student writes r by 2 gm whole power half, that is square root of r by 2 gm for a escape velocity of dot. Check the correctness of the formula using the dimensional analysis, where r is the radius of dot, g is universal gravitational constant, and m is the mass of the earth. Let's begin. Escape velocity v equals to r by 2 gm whole power 1 by 2. It's a formula given by the question, or simply a student writes this as a escape velocity. Now we have to check whether this formula is dimensionally correct or not. In terms of dimensions of LHS B is, that is velocity LT minus 1. Similar dimension of the right side, R is the radius length, whatever, it has the dimension L. 2 is the numerical value, that is simply the number, it has no dimension. G has the dimension M minus 1 L3 T minus 2, and M is the mass is the dimension M. And simplify it, you will get L minus 1 T minus 2, that is M cancel, and remaining quantity just simplify, we will get as L minus 1 T minus 1. So what's your conclusion? Dimension under LHS is not equal to dimensions under RHS. So we can conclude that the given physical relation for the escape velocity is dimensionally wrong. Now let's go for the next problem. Once again, a student reports that the time period of a helical spring is T equals to 2 pi m by k, where k is the force constant. Is he right? If not, what is the correct equation? The physical equation according to question, time period T equals to 2 pi m by k. 2 pi is a dimensionless number, and dimension under LHS T is obviously time period T, and for the dimension under RHS, that is 2 pi is dimensionless, dimension after m. Before once again, m as a mass, and what is the k? K is the force, constant force per unit length, simply ml by f. M is the mass has the dimension m, L is the length, dimension L, and force has the dimension ml T minus 2, that is simply ml cancel, that is T2 is the dimension on the right side. Since the dimension on the left side is not equals to dimension on the right side, the given physical equation is dimensionally wrong. What can be done to correct the given physical equation? If we take the square root after t square, that is t. So in such condition, dimension on the right side also will be equal to the dimension on the left side. If we take the square root on the right side for the physical quantity m by k, the given physical relation will be correct. So the correct physical equation is T equals to 2 pi square root of m by k. Now once again, cross similar question. Test dimensionally if the formula T equals to 2 pi square root of m by k, where T is time period, m is the mass, and k is the mass per unit length. Once again, go for the left hand side, go for the right hand side, you will get dimension. This correct physical equation is dimensionally correct. Take your time, pause the video, and once check it whether this formula is dimensionally correct or not. Within a minute you can check it. I'll proceed for the next problem. If the centripetal force is of the form of ma bb r power c, find the values of a, b, c. Here the centripetal force F equals to m power a, b power b, and r power c. Now in terms of dimensions, we'll write the equation as, for the force ml t minus 2, it must be power ml t minus 2, m is the mass, m power a, b is the velocity, l t power minus 1 b, and l power minus c. Simplify the relation, we'll get as m power 1 l power 1 t power minus 2 on the left hand side, and m power a l power b plus c, and t power minus b, from this term minus b, and compare the powers, or with the corresponding term, just compare the exponent of the, for the mass m equals to as the power 1, that is a equals to 1, b plus c is 1, and minus b is minus 2. Then A is already got the values minus b equals to minus 2, that means b equals to 2. Replace in a b plus c, you will get c equals to minus 1, and these are the values of the a, b, c. If we need a physical relation, just replace the values of a, b, c in this equation. F equals to m power a, b power b, and r power c will get released as F equals to mb square by r as a centripetal force. In this way we can find the values of a, b, c using the dimensions or simply physical relation. Okay, let's see one more problem. The velocity v of water waves may depend on the wavelength lambda, density of water rho, and acceleration due to gravity g. Find the relation between these quantities by the method of dimensions. Let's see. According to the question, as per mentioned in the question, v is proportional to lambda rho g, but we are not familiar with the factor ABC. We have to find ABC using dimensional analysis. Rewrite this relation in terms of the dimension. Before b equals to just remove the proportional sign, k lambda power a, rho power b, g power c, where k is a dimensionless constant. Now in terms of the dimensions, rewrite the equation 1. We'll get for the velocity lt minus 1, k has no particular dimension, it is dimensionless constant. Lambda is the wavelength, dimension L. Rho is the density, ml power minus 3 power b, and lt power minus 2c. Rewrite to this equation, we get in general m0 l1 t minus 1 and mb. There is only one term for the mb, and L a plus L power a minus 3b plus c. Second equation, second term, and for the time only t power minus 2c. As before, just equate the exponents of the similar quantities for the b equals to 0 from the first. Similarly, a minus 3b plus c equals to 1, and minus 2c equals to b equals to 0, obvious, that is, then c equals to 1 by 2. Now replace the value of b and c in equation. This equation, a minus 3b, b is already 0, a minus c, a plus c is only left, and we replace the 1 by 2, that is simply gives once again c as 1 by 2, and substitute the value, we'll get b also 1 by 2, sorry, a equals to also 1 by 2, b equals to 0, b equals to 0, a equals to 1 by 2 once again, and replace the values of a, b, c in equation 1. We get b equals to k lambda power 1 by 2, rho power 0, b equals to 0, g power 1 by 2 once again, and simply k lambda half, g half, or that is we can write b square is proportional to lambda g. In this way we can find a relation between the given physical quantities using the dimensional analysis. One more problem. The force F is given in terms of the time, and displacement x is given by the equation F a cos bx plus c sin dt. F is the force, x is the displacement, and t is time, and a, b, c, d are the unknown quantities. And what about the dimensions of d by b? Trigonometric functions are dimensionless. Your cos bx and sin dt are dimensionless. That means bx and dt have no dimensions. Bx and dt have no dimensions. So in terms of dimensions, they must be equal. Given physical equation once again is F equals to a cos bx plus c sin dt, and bx and dt are dimensionless because they are trigonometric functions. So dimension of the Bx must be equals to dimension of the dt. About the dimension of B, we are not sure. We are not that's unknown quantity. X as the dimension of displacement L and T as the dimension of the, so d by B equals to L T minus 1. In this way we can find the dimension of d by B. And this is the end of the lecture. Don't forget to subscribe and share, like and comment. And if there is any comments, queries, may suggest comment on comment box, or may forward through this email address readersimplifiedphysics@gmail.com. And for the Facebook, you may forward the message through the Facebook as well. Thanks for watching.